Welcome to your third YouTube lesson. We're going to focus on reducing the risk of desertification this lesson, so it directly links back to the last one. I just want to say, don't be put off with the length of this video. There are 3 YouTube videos embedded within this that we're going to watch that are really useful, so it's not just me talking at you for a long period of time. Just before I start, I want to say a massive thank you from myself and Miss Madare to all those students that have sent us their work. Really well done, you're working very hard, so thank you. Okay, so objectives for today: we need to identify ways to reduce the risk of desertification, explain those ways and how they work, and then lastly we need to evaluate the ways. So are they useful, are they effective at managing that? So just as a reminder, desertification, there's a definition up there, is the process by which fertile land becomes desert, and it's typically as a result of things like drought, deforestation and inappropriate agriculture. Okay, we need to have a look at where desertification is happening. Now, we had a look last lesson at areas that are vulnerable to desertification, but we're going to zoom in and look at a particular region today. So this region is the Sahel region, and it's a narrow belt of semi-arid land that extends across Africa, and the Sahara Desert in this region is actually spreading around 400 meters south each year. So these areas are on the fringe of hot deserts and are at real risk of environmental damage caused by desertification. Okay, before we have a look at the 3 different methods to reduce desertification and to manage that, we need to know what this term means, and it's appropriate technology. So by appropriate technology, what I mean is a lot of people that live in areas vulnerable to desertification are often poor. So whatever is put in place to manage desertification, we need to think about, well, is that appropriate for the people that live there, the money and the resources that they have? They may not have many resources or machinery or materials, and when they know they don't have a lot of money, so whatever's being put in place, can they continue to run that themselves with little support from others? Okay, so the first one we're going to have a look at is known as planting pits or Y pits. So we're going to watch the video. Whilst you're watching the video, jot down bits that you take from that video, especially about how planting pits work to reduce desertification, so to stop the land becoming infertile, and think about, well, is it appropriate technology? Can the people living in that region manage that themselves? Bear with me while the video just loads.
In semi-arid Africa, rainfall runoff can be turned into a productive resource through water harvesting. In Burkina Faso, stone lines on the contour slow down runoff. But when combined with Y planting pits, the system is doubly effective. Based on a tradition, but improved by farmers and field agents, these wide and deep planting pits can be used on their own, or even better, together with other measures. But in all cases, they act the same way, capturing water runoff that flows over the surface. Y are dug by hand with a hoe. They're usually around 25 centimeters in diameter, about 20 centimeters deep. meters apart in each direction. Excavated soil is placed downslope of the hole. Composted manure is precision placed in the zai before millet or sorghum is sown. So when it rains, both moisture and fertility are concentrated exactly where they are required. Ali Ouedraogo was amongst the pioneers of these improved zai, and Salif, his son, has taken over where his father left off.
The benefits of zai are numerous. We put compost and organic manure into the zai. This allows us to make best use of them. We grow cereals and cowpeas, and the crop residues provide forage for the animals.
Salif, like others, appreciates how supplementing the zai with stone lines means that fertility isn't just added through manure, but by the action of the lines slowing down the runoff, which encourages rich sediment to settle in the zai. In this area, cereal yields are said to have improved from 1/4 of a ton per hectare to more than double that, thanks to the triple combination of stone lines, zai, and composted manure. Naturally, the benefits vary from season to season, but which family invests 3 decades of effort in a system that doesn't pay back? Amadou Kindo is another smallholder who's convinced. Despite being disabled, he's a skillful and industrious farmer. Amadou has brought barren terrain, or Zipele as it's known in Burkina Faso, into cultivation. Desertification has been effectively reversed by a hoe, runoff capturing holes, and manure. As well as crops, Amadou nurtures tree seedlings that have germinated in his zai. He carefully prunes balanites and acacia trees, and uses the trimmings for mulch. Another innovative farmer, Y10 is trying out semi-mechanization of zai to reduce labor input. A horse-drawn ripper opens lines, and then a modified rake is dragged at right angles to mark out the sites for the zai. Finally, the pits are dug in the loosened earth and manured. But planting pits are not only used in Burkina Faso. Neighboring Niger also had traditional pits called tassa. Malam Ali was amongst the farmers' delegation that visited Burkina Faso in the 1980s. This was part of the farmer-to-farmer extension strategy embraced by an early project. They learned improved techniques for reclaiming land, and Malam Ali began to implement those on his return to Niger.
The difference is as follows. We used to dig the pits in a haphazard fashion. Now we have learned to dig wider pits and to make them point upslope to capture water.
Once again, this practice of improved planting pits, tassa, together with another water harvesting technique termed demi-lune, has survived, been passed to the next generation. Samaila Ali is Malam's son.
Who is there who has not reached?
Okay, so I'm going to pause that one there, Y10, because I think you get the message of planting pits from that clip so far. So what we're going to have a look at now is using your notes from the video and what you got from that. I want you to pause the video and summarise how planting pits or Y pits help to manage desertification. So think about how they help manage the water and the rain, and think about how they help the soil. And then, is it an example of appropriate technology? Can the people living there manage that and do that themselves? So pause it now and have a go. Okay, second method is stone line. So again, if you get a pen and paper ready and jot down some notes about how stone line works, hopefully this video will work. I'm sorry for the delay in getting them played.
In the Sahel during the 1970s, droughts led to land degradation and hardship. Some families Even when rain fell, it ran off the compacted surface, carrying nutrients with it. But here was an opportunity as well. The abundant surface stones could be arranged in lines across the contour to slow down and spread that flow. A few farmers, in fact, had practiced this traditionally. Development agencies picked up the idea of improving and promoting this simple, cheap water harvesting system. One project in Burkina Faso used a model and a watering can to show farmers how the system worked. A contour stone line, some 25 to 30 centimeters in height, acts as a semi-permeable structure, slowing down runoff water and allowing the deposition of rich sediment behind the barrier, so less erosion but more water for the crops. This makes it a very effective adaptation technology. Farmers were trained in laying out contours using a simple water tube level. And shown how to construct improved lines by digging a foundation trench along the contour, then placing larger stones first, followed by smaller ones. In situations where there is not enough stone, and to improve the effectiveness of the barrier, Anthropogon grass can be planted. Emphasis has been on encouraging villagers to work together, making rehabilitation of land a collective effort. Stone line construction was at a peak in the 80s and 90s, but still continues as more degraded land is brought back into cultivation. The technique has spread from Burkina Faso to neighboring Mali and Niger, and further into the Sahel as well. Exchange visits of farmers have helped to spread the message. This is a technology that's based on a tradition, which, with technical improvements, makes use of locally available resources. It's low cost and requires skills that can be quickly learned, but that knowledge in itself is empowering. Stone lines are the foundation upon which other conservation and production elements are built. Planting pits, termed zai in Burkina Faso or tassa in Niger, help hold water around the plants. And homemade compost, as shown here, or microdoses of fertilizer improve yields. Farmer-managed agroforestry systems complete the productive picture. The question now is, how have those first stone lines functioned over the years? And the answer is extraordinarily.
Okay, so just pause that one there because it starts to mix the two together, which I want you to think about in a little bit later on in the video. So what I want you to do is pause again and have a go at those two questions. So summarise, how do stone lines help to reduce the risk and manage desertification? Think about how they help to manage the water, the rain and the soil, and is it an example of appropriate technology? So pause now and have a go at that. And then the last method that we're going to have a look at today are acacia trees. So again, bear with me while I get the video playing, and do the same, jot down some notes, always have in mind, how does it work? Does it help to reduce the risk of desertification? And is it appropriate technology?
Less than 50 years ago, this land was lush savanna. But here, as in much of the Sahel, the 5,000-kilometer belt of land that divides the Sahara Desert from the rest of Africa, vegetation has been disappearing. Climate change leading to prolonged periods of drought, land degradation caused by over-farming and overgrazing, as well as deforestation, have turned this once fertile land into desert. But a recent project to plant acacia or gum trees is attempting to reverse that process of desertification.
Bi nga xamante ne boobu amaguñu projet bi booba ndax am daanuñu pay rek ci àll bi di récolter ak suñuy loxo di yóbbu ca kër ga waaye booba kaaraange gi ñu am ak garab yi ñu am mu taxaw ci biir tool bi amuñu ko woon parce que garab yi fi nekkoon yëpp ya maam ñoom yu yàgg ya dañu fee jóge woon nekkutuñ fi woon.
Fatou Say is one of 150 women in this village alone, benefiting from a project begun in 2004 by the United Nations Food and Agriculture Organization, or FAO, together with the Forestry Department of Senegal and 5 other countries across the region.
Pour les populations, ce qu'on a constaté, c'est que avec l'exécution du projet, avec sa mise en œuvre, les populations ont changé de mentalité et de comportement. Les populations ont mieux perçu les effets et les impacts de l'arbre dans leur vie quotidienne, dans l'activité socio-économique.
FAO, together with the Forestry Service, provided seeds and seedlings and taught them how to sow and plant the acacia trees, as well as how to extract and market the gum they produce. They were given a tractor with a digger tool, specially adapted to dry land conditions. The half-moon-shaped holes collect rainwater, ensuring that the young plant roots will have enough water to overcome the long dry season.
Fare la buca è molto fatica e poi se ne fanno poche al giorno. qui si scavano 2-3 metri cubi di terra al giorno, una persona. In Cina i cinesi mi hanno detto sempre, ma noi ne facciamo 5 metri cubi. Ma il mio sistema ne fa 7.000-10.000 metri cubi di scavo al giorno.
Planting of the acacia trees reverses desertification by preventing soil erosion and providing nutrients for other plants and crops to grow. The trees also remove carbon from the atmosphere. Good news from an environmental perspective, but also for the tens of thousands of people living within the Sahel.
Acacia is a good choice for the project because it is a native tree, so we are not altering biodiversity. It's a tree which has many benefits. It feeds the soil, so it restores its fertility. It is a shelter for crops. It is also providing gum arabic, which has an international market and good for the economy. It also provides fodder for livestock and also food for also the local communities.
In a region home to many of the world's poorest countries, the project is changing attitudes and...
Okay, so I'm going to pause it there because I think, again, you get how Acacia Tree works from what's been said in the video so far. So again, in a second, if you can pause and you could summarise how Acacia Trees help to manage desertification. Think about how they help to manage water and the soil, and is it an example of appropriate technology? And next thing that I want us to have a go at is assessing and weighing up. So you've learned about 3 different ways to manage desertification. Things which thing is the best way to manage it, and bringing that together, I've just a little summary here about how useful these methods are, and how they're both important and maybe then some issues meaning they're not important. So some of them are cheap and simple, local people can use them, it increases the soil fertility, the roots of the trees, for example, bind the soil together, and there are some examples there of appropriate technology. However, on the other side, you have to think about the scale of this. Is it too small? I know the acacia trees have had a much bigger scale impact, but you have to think about the scale of it. They require some help setting up. So I know the Acacia Tree programme, they had help from charities to set that up. They had help with machinery to make it a lot better and more effective. And could it be more effective if they had better or appropriate technology? Okay, so we're just going to bring everything back together and have a look at how this would appear in an exam. So this is an example of a question that could come up. Choose one of the following environments. So an area on the fringe of a hot desert or a cold environment. So we always pick the hot desert. And for your chosen environment, assess the importance of management strategies used to reduce the risk of environmental damage. So again, we'll bug it to break it down. So assess, that's weighing up the importance of these strategies. Are they important or are they not important? And then the geography management strategies, we've just looked at the 3 videos. And then what is the environmental damage? Well, it's desertification. So this is how you'd be able to get a top answer. So at the end of the video, I want you to pause it on this slide so you've got all this in front of you. So show some knowledge of the environmental pressure that's put on these areas of hot desert, so around this Sahel region. So talk about desertification, give a definition of desertification, explain how the management strategies, so say how stone lines work, say how planting pits work, and so on. And then you need to reach a decision about how important they are. So think back to the last slide, but what was important about these strategies, but then maybe what were some issues or some reasons why it's not as important on a bigger scale. And to get you started, I put some sentence starters there. I'll not talk through all of them with you. If you just want to pause the video, and then you can use them to help you. Thank you very much again for joining the YouTube video lesson, and please don't forget to send me or Miss Medea your work, depending which class you're in, either on Teams or on email. Thank you.